Hi, ENCE 411. My name is Sarah Igielski, and I will be your teaching assistant this week. So I put together a brief PowerPoint presentation just so you all could get to know me better, and it felt super awkward just talking into the camera with no context. So here we go. I am originally from New York. I grew up in Pleasantville, which is in Westchester County. And then I headed down to Maryland for college. So growing up, I was super interested in math, science, physics, and I always knew that I wanted to do something with that. I didn't exactly understand what my career options were until probably senior year of high school. I was taking AP chemistry and they had a volunteer from Engineers Without Borders come in and give us a presentation. And that conversation really resonated with me. It made me understand what value a civil engineer could bring to our communities, to society, to our scientific community. And that made me really excited. And it definitely inspired me to pursue the path of civil engineering as opposed to just any other engineering discipline. And also made me really focused on water. Growing up, I definitely felt a connection to the outdoors. I'm showing a picture here of Rockefeller State Preserve, which is a natural park right where I grew up, where I spent a lot of time. And so after hearing that EWE presentation, things just started connecting, and I started thinking a little bit more seriously about how I wanted to spend my time at Maryland. So while I was at Maryland, I majored in civil engineering and I minored in sustainability. And within civil engineering, like most of you, I focused on water resources and environmental engineering. Starting my sophomore year of college, I started doing undergraduate research with Dr. Alan Davis and got really involved in stormwater research. I learned a lot about the Chesapeake Bay, TMDL requirements, big focuses on total suspended solids, big focus on total nitrogen and phosphorus. And so through all the different innovative technologies they were using, I really focused on total nitrogen, and I specifically focused on the nitrogen removal process known as denitrification. So through my understanding of eutrophication and then further my understanding of the nitrogen cycle, things started, I guess, coming together in the research lab. I worked under a couple of graduate students for a while. And then starting the beginning of my senior year, I started leading my own graduate project. So what I specifically focused on was urban stormwater denitrification in a bioretention cell. And essentially, this is our final step in the nitrogen cycle. It's really easy to produce a lot of nitrate in your standard bioretention cell. The challenge is actually getting that nitrate to be completely removed to the process of nitrogen gas. And that's where my research came in. So starting senior year and then going into my 5th year, which is how I did the BSMS program, I really started asking a lot of questions. And we started completely on the laboratory-based experiments. I had the opportunity to collaborate with the University of South Florida in Tampa, and then also Dr. Kellerup. My research was actually funded through USF, and so that's where that partnership came about. What you're seeing as a photo on the bottom left is actually a field demonstration of the work that I was doing in the lab. So while I was only doing laboratory-based experiments, another research fellow was actually working on her doctorate degree, and she was doing those same experiments in the field to see how we compared. So what we really looked to do was to simulate that underground storage cell, and that cell is going to be completely saturated. It's going to have an external carbon source, which we used as wood chips. And then it has pea gravel just as kind of a filler media without giving us too much excess carbon. So looking through the whole research process, we wanted to demonstrate that denitrification is occurring. And we also were able to identify the presence of denitrifying bacteria. We defined first order kinetics rate constant, and we also identified what would be the minimal hydraulic retention time for 20% removal of nitrogen by mass. And that's really where we started to see kind of a push and pull between people that are focused on just water quality and people that are focused on water quantity. When you want to get water off the streets, you're really just thinking out of sight, out of mind. But when we're looking within the context of TMDLs, we're really focused on that water quality component. And denitrification is a really, really slow process. So while you want to get your water through your cell relatively quickly, for this process to even be effective and to actually start seeing any type of noticeable results, I think we came up with about a 4-hour minimum retention time. Finally, we wanted to analyze our nitrate as nitrogen removal under various hydraulic loading conditions. So what this means is we wanted to actually take what is defined as typical Maryland stormwater events or rainfall events, transfer that to a stormwater runoff, and actually apply that to our bioretention cell, specifically in that internal water storage zone. So again, we're trying to get some type of real-world application to what is only a laboratory-based experiment. What you'll also notice is that the entire column is wrapped in tinfoil. That's again to simulate those below ground conditions. So when it's wrapped in tinfoil, there's no light getting through that. All the way on the top, right, the tinfoil is just taken off just so you can actually see what the media looks like. And then all the way on the bottom right, that is actually part of our drainage configuration. So to keep the system permanently saturated, you have to incorporate an upturned elbow, which is what we were doing here with this pipe. It looks really gross and really dirty because that's actually part of what happened in our system after a year of continuous operation. So this is just a lot of sloughing that's happened off of our biofilms and not exactly part of the denitrification process, but gives us an understanding of a lot of activities happening in that cell. And there was no feeding of the system. All of the denitrifying bacteria and other microorganisms that we identified all stem from the wood chips themselves. Okay, so enough about research because that was a real test to my memory. Moving on to after I graduated from Maryland, I moved back to New York City and I joined the consulting world. So I totally left academia, and when you enter consulting, consider yourself to be a trusted advisor. I think that is kind of the best way to describe the work I do now. So working in New York City, most of my clients are New York City based, and they hire consultants or engineers like myself to actually design, oversee construction, help with operations to get something done. And I had the opportunity for my first job out of consulting was with a company called Greeley and Hansen. You may have heard of them. They are a very small water wastewater consulting firm, but they do have a pretty strong presence in the UMD area. They have an office in Silver Spring. They have a permanent trailer down at DC Water, and they also have about 3 offices in Virginia. And it was an absolutely incredible experience working for them in New York City. I had the opportunity to work on a variety of big capital plan projects. And one of them is called the New York City Wastewater Resiliency Program, and that is for New York City's Department of Environmental Protection, or we just say New York City DEP. And this is really focused on helping the city better adapt to climate change, sea level rise, and Hurricane Sandy that happened back in 2012 really exposed the vulnerabilities of our wastewater infrastructure. There was already momentum in place from the early 2000s where we knew that all of these low-lying wastewater resource recovery facilities were vulnerable. What we didn't know was how vulnerable they really were. And so when Superstorm Sandy came, all of that was exposed. And it was a really eye-opening experience for the city in where they accelerated this program. And so this is a massive program. It encompasses 14 of the 96 pumping stations and also 13 out of the 14 wastewater resource recovery facilities. And what they're doing is a proactive approach. So we're looking to essentially harden all of our wastewater infrastructure. We're not building flood walls, but we're actually looking at it based off of a process or a building standpoint, and how can we protect that from the expected flood levels, storm surge, tidal forces that we might be getting down the road. And we're looking at this all the way out until about 2075. So these are big predictions that we're taking, and things are looking like they're getting a lot worse. And so the program in itself really ties into New York City climate change and their One NYC goals. This is something unique to New York City, but I would say pretty much any big city that you're looking at is going to have some type of acknowledgement plan in place to address climate change. And that's where we're seeing a lot of really interesting work right now. So when we're looking to harden this infrastructure, it's really important that we don't just think about it from the capacity of how do I make a wall thicker so that it's stronger? Or how do I replace this door with a flood door so that water can't penetrate? It's actually a lot more in depth, and it really is about the understanding of wastewater processes. And so what I'm showing you in the photo on the top left is an example of what's called a process flow diagram. And this is an overview that you would see at any wastewater facility when you first walk in of all of the treatment processes they have, both liquid and solid, and how everything is working together. It's not giving us the details, it's just a high level understanding. And beyond just understanding the processes, we want to understand the vulnerabilities. So if you look at the photo on the top right, that's a picture of a chlorine filling station or sodium hypochlorite filling station that's used for disinfection. Disinfection is happening right before our wastewater is discharged into a receiving water body, which means most likely you're going to see systems like chlorination exceptionally vulnerable. They're going to be right up along the water, and that's no different in this plant. So understanding not only about how to make that wall thicker, well, there's a challenge there because we have all these process and chemical fill pipes. What do we think about differently? How can we adapt and use different resiliency strategies in our toolbox to not only maintain processes, but also protect it from future storms? And so that kind of leads us to that last component of the resiliency program, and that's about understanding operations. So you can read drawings as much as you want, and what we've always found is you can only learn so much. It's always about the conversations that you have with your operators and people that are working in the field day to day, where you're going to get the most knowledge. And if you do have the opportunity to visit different wastewater facilities or drinking water plants, I highly encourage it. So to my last point, when you're a trusted advisor, and that really just is what we call consulting, you have the opportunity to work at various project phases. When I'm talking about the New York City Resiliency Program, I was involved at the onset of the project start, so that's what we call planning, and then through the design phase as well. But there are opportunities to be involved during construction, overseeing the contractor in construction or the design in construction, and then looking at that closeout phase as well. Another project that I worked on when I was at Greeley and Hansen is part of the New York City Green Infrastructure Program. This is prompted by a New York State consent order, which is telling a state that you have to manage the first 1 inch of stormwater runoff within 20% area of a priority CSO park. So most of New York City, I would say about 2/3 of the area, is covered by what's called a CSO, or a combined sewer overflow system, meaning your storm and sewer are together. And so there's a really big challenge in that when we get even 1/8 of an inch of runoff or rain, that generates enough runoff in New York City to overwhelm our system. That means that we can see localized flooding. That means we're going to have overflow events so that our storm and sewer water is not getting treated at the wastewater plant. It's actually just getting pumped out to a receiving water body, and it causes a lot of environmental problems. So one thing we look at, of course, is green infrastructure. And this part of the program, we actually introduced a pilot technology for New York City DEP. We looked at permeable pavements and porous concrete panels. So what you're seeing all the way on the left is what is our porous concrete panel. And this is one of the examples of maintenance that we tried to understand better so that we could ultimately provide a recommendation to the city about how to best maintain such a very sensitive system. To continue to manage and quantify the permeability or the infiltration rate through our porous concrete and our permeable pavement, we did adopt and modify an ASTM method to do that, which is why you're seeing a Home Depot bucket ring on that concrete. We essentially just fill that water to a specified height, maintaining that water head, and we can translate that into an infiltration rate. The third picture is a picture of the construction. This is actually how the permeable pavers are installed. You excavate a big trench, you line it, you've got 2 layers of 2 different size, clean, open graded stone, and then you physically place each of the individual pavers one next to another. So they fit super snug, about a 1/4 inch gap between them, and the contractor can do them very, very quickly once they get the hang of it. So Greeley and Hanson was involved in the design, the construction oversight, and post-construction, all of which I had the opportunity to lead. So I would say just another big part of my professional career is actually outside of the office. And I'm titling this Investing in the New York City Water Community because I think it's more than just doing engineering calculations. It's more than just giving presentations about the work that you've done. It's really about taking an investment in your peers, taking an investment in your company and in yourself and in your community. And I think a great way to do that is through professional organizations. So we have our National Water Environment Federation, WEF, and within that they have member associations based off of your geographic location. So for me in New York, it's called the New York Member Association is actually called NYWEA, which is New York Water Environment Association. And then broken down even further in New York, they have 5 different regions. I am part of the metropolitan chapter, being that I'm in New York City, and I also hold the role of the Young Professionals Chair. Young Professionals is typically anybody that is under the age of 35 and or has under 10 years of experience in the industry. So through this organization, we host a lot of volunteer opportunities that you can see in the top 2 photos. We host networking events when they were appropriate in person. We had quite a number of them. And at the end of the day, it really is about building connections. New York City is an incredibly large city, but being in NYWEA has made a big city feel really, really small. It is such a close-knit community, I would say, between our water, wastewater industry professionals. And so being involved in the Young Professionals Committee has offered me opportunities to build relationships with clients, build relationships with more experienced professionals in other companies, and just give me a really good exposure and pulse of what else is going on. And so I definitely encourage anybody that's joining our industry, wherever you may be, look what your WEF member association is and join that and get involved. So finally, to what I am doing right now. As of last month, I joined Carollo Engineers. It is also a water wastewater consulting firm, and this is definitely a very new opportunity for me. If you haven't heard of Carollo, that is okay. We are just joining the East Coast right now. They opened up an Arlington, Virginia office about 4 years ago now, and as of earlier this month, we have officially opened a New Jersey and New York City office. So a company that was founded in 1933, predominantly on the West Coast, California, Texas, New Mexico, Nevada, is now looking to expand east. And so I am super excited to be part of a new team, a new region for the company, and really helping them grow. So what I'm showing here is just a couple of examples of really the work that we're going to be doing. We're targeting new clients in New York City DEP. We're targeting new clients in New Jersey. And this is a super exciting time. So I'm definitely putting my engineering skills to the test, but also my networking skills. So super excited about that. So finally, now that I've talked about myself enough, how can I help you? Well, I'm super excited to be your TA this week. I want to help you as best as I can, and that's not just going through the technical modules that I do have prepared for you guys. I do want you to be able to develop your technical skills from this. I hope it challenges you, but I really hope that you get something out of it because I do think it has real world application. It's calculations that I've done, it's work that I do, and I think it's great to have that exposure ahead of time. But if you don't just want to talk technical, please feel free to reach out to me regardless. I am always happy to talk about career advice. If you are uncertain about graduate school or you just kind of want to talk and understand my experience a little bit better, I'm happy to do that. If you are looking for resources for success, please don't be afraid to reach out. It is definitely a unique time. The job market is different. We are networking differently, and I want to help you build that network. I want you to put your best self forward, and I'm ready to help any way that I can. So I'm looking forward to working with all of you guys, and we will talk soon. Bye, everybody.